let us look at a summary of the maximum point, minimum point, and saddle point. All right. So the maximum point, something like this. We have along the x and the y-axis. The first derivative, first partial derivatives would be 0 because they are at the top of the hill. They are at the maximum point. And then as you move, you have to go downwards. Alright, because you're already at the top, you'll have to go downwards. So while a tangent at the top is horizontal, has a 0 gradient, when you move in the positive direction of x or y, you would have it tending to move in a negative. The gradient would become more negative. It's always becoming more negative. So what you find is that for the maximum point, you have delta x or delta f, partial derivative of the function with respect to x, is going to be negative. Is going to be equal to 0. In order for you to locate the maximum point, partial derivative of the function with respect to y is also 0. You solve them simultaneously to find the location. Now the second partial derivative of the function with respect to x will be negative. Also, the second partial derivative of a function with respect to y is also negative. Alright? Now, if you have a minimum point now, in this case, you're already at the bottom of the valley, and right at the bottom of the valley, the delta f by delta x, also delta f by delta y, both of them are 0. Alright, so here for the minimum point, both of them are 0. But as you move in the positive direction from there, you will find that the gradient of the tangent increases. In fact, it will always increasing. And you will find that the second partial derivative will be positive for x and positive for y as well. Alright? Now, you also have another case, that is a saddle point, when one of these is positive and the other is negative. So for the second partial derivative of x is positive and for y is negative, or for x it is negative and for y it is positive, then you have a saddle point. Alright, so in this case it's a saddle point. Now you have a formula that says if you have delta squared f by delta x squared multiplied by delta square f by delta y squared minus delta square f by delta x delta y all squared if that is greater than 0, then it is a minimum or maximum point. Now, this is greater than 0, meaning that this is positive. If this is positive, then this must be the greater one. So, if delta squared f by delta x squared times delta squared f by delta y squared is greater than delta squared f by delta x delta y all squared, then you have a minimum or maximum. Now, here, it also means that if delta squared f by delta x squared multiplied by delta squared f by delta y squared is less than delta squared f by delta x delta y, then you have a saddle point, right? Now, by the way, remember that delta squared f by delta x delta y is the same as delta squared f by delta y delta x, alright? Now, let's look back at this. If you have a negative times a negative, and this will become positive. So, this multiplication will be a positive, alright? Now, in this case, you'd have a negative times a positive or a positive times a negative. So this is a negative, right? So this can be less than this, alright? So here now, those are the ways that you can determine whether you have a maximum, minimum, or a saddle point. Alright? So, here now, what we're going to do in our next video is to look at a few examples. So I'll see you then.